It wasn't too long ago in automotive history that heaters and other climate control features were considered quite a novelty. Take a look at the heater of this 1934 DeSoto, for example. By opening these two little doors, you can regulate just how much heat you want. Today's owners, however, expect driving to be a comfortable and pleasurable experience, with many of their climate control adjustments made automatically. And Chrysler has met the demands of even the most selective driver with automatic temperature control systems, offered on Chrysler domestic-built New Yorker and Conquest, built by Mitsubishi Motors and imported for Chrysler. Computer-actuated automatic temperature control, or ATC, is available for the first time in 1986 domestic-built Chrysler New Yorkers. This system, as described in the operating instructions and product information booklet, offers increased flexibility in the selection of comfort settings, air direction, and operating tips, which include a chart as well as a list for the most desirable settings for specific weather conditions. The automatic controls in the system help reach desired temperature levels as quickly as possible. This is accomplished by a computer, which regulates the incoming air to provide the desired comfort level. The computer measures interior temperature and, if needed, makes adjustments every 8 seconds. In hot weather startups with AC on, the system automatically provides maximum cooling. When operating the vehicle in cold weather, the system delays blower operation for up to 4 minutes. Depending on outside temperature, this helps prevent cold air from blowing on the passengers. An exception is the defrost mode, in which fan operation is always immediate. The attractive control unit has soft touch precision feel buttons and a vacuum fluorescent display window. The display uses International Standards Organization symbols, or ISO, to indicate fan speed, temperature setting, and system operating mode. With headlamps on, display intensity is adjusted with the instrument panel lights using the headlamp switch rheostat. Fan speed is adjusted using the rocker switch with the fan symbol. Pressing the top of the switch increases fan speed. Pressing the bottom decreases fan speed. Fan speed is shown on the left side of the display window using the fan symbol. At the lowest fan speed, only the bottom left segment is illuminated. As fan speed is increased, successive segments are illuminated. The display has 8 segments, although 25 fan speeds are possible. The desired temperature is displayed next to the fan speed symbol. Temperature is adjusted using the temp rocker switch. Pressing the top of the switch increases the setting. Pressing the bottom decreases it. The ATC provides an available temperature adjustment of 65 to 85 degrees Fahrenheit or 18 to 30 degrees centigrade. In the temperature range between 66 and 84 degrees Fahrenheit or 19 to 29 degrees centigrade, the system will be controlled automatically. Holding the temperature switch down for 4 seconds at the 65 degree setting locks the system in the max AC mode. The 85 degree setting locks the blend air door in the full heat. Incidentally, by simultaneously pressing the bi-level and defrost buttons, the system changes from US units to metric. To the right of the temperature display, an operating mode display shows which airflow outlets have been selected. When all 3 arrows are displayed, bi-level operation is in effect. Curved arrows pointing to the side indicates the panel button has been pressed. A single arrow pointing down indicates the floor button has been pressed. There are 2 additional symbols to the right of the airflow indicator. The snowflake symbol is illuminated when AC is in operation. The defroster symbol is illuminated during defroster operation. The computer-controlled ATC system uses the same air distribution, heater, and air conditioning components as the manually controlled systems on similar front-wheel drive vehicles. Thermistors are used to measure ambient air temperature and interior temperature. The ambient or outdoor air sensor is mounted within the fresh air inlet of the heater AC unit. The interior temperature sensor is mounted behind the steering column lower cover and to the right of the steering column. A small electrical motor-driven fan draws air across the sensor to obtain accurate measurement of the interior temperature. The brains of the ATC, the computer, is located within the control unit and is serviced by replacement of the unit. Mode switching is handled by 5 vacuum solenoids located in the power vacuum module and controlled by the computer. Also, within the power vacuum module are 2 relays to control the high blower motor and AC clutch. This unit is mounted on the front of the ATC evaporator package. Temperature is regulated by a conventional blend air door, accurately positioned by an electric motor. A sensor automatically relays door position back to the computer, maintaining precise control of the temperature. The ATC system includes a self-diagnostic feature for all aspects of the system, including electrical components unrelated to the electronic control. However, diagnostic procedures should always begin with a verification of the complaint to ensure that there is in fact a problem with the system. This requires the service writer to thoroughly and accurately convey the thoughts and problems of the customer to the technician. Sometimes invalid complaints are the result of an owner not knowing how to use the system properly, and therefore verification should never be overlooked. The technician should always refer to the service manual sections on automatic temperature control. They include ATC test and diagnostic procedures, non-computer aided diagnosis, pre-computer aided diagnosis, and computer aided diagnosis. Before beginning the computer aided diagnostic tests, the technician should always begin by checking the coolant level, drive belt, refrigerant charge, engine vacuum connections, radiator airflow, radiator fan operation, and in-car sensor air intake suction. After checking these items, bring the engine to normal running temperature and then proceed with the automatic temperature control system's computer-aided diagnostics. The test cycle, which can troubleshoot the system in 90 seconds, is started by depressing the bi-level, floor, and defrost buttons at the same time. While in this mode, check that all display symbols and indicators illuminate. Check blower motor operation and airflow from panel outlets. And also check that the outlet air temperature changes from hot to cold. If the test finds a failure, the code number will appear on the control readout. After recording the code, press the panel button to proceed. All failure codes are recorded in this fashion, with the exception of number 3. If failure code 3 appears, push any button except panel to stop the test. Repairs, as outlined in the service manual, must be completed before retesting the system. A 3-bar 75 defrost setting will indicate that the test cycle has been completed. Using the service manual as a guide, the technician can accurately pinpoint where the problem in the system originates. For instance, failure codes 1, 2, 3, and 4 involve the blend air door, feed wiring, and control computer. Failure code 5 involves the control computer. Failure code 6, 7, 9, 10, 11, 12, and 13 involves the feed wiring, vacuum module, and control computer. Failure code 8 involves the power or control module. Failure code 14 involves the in-car sensor or control module. And failure code 15 involves the ambient sensor or control module. These circuits can be tested at different locations on the vehicle with the use of an ohmmeter and a voltmeter in order to further isolate the problem. Remember, when using the service manual, follow all procedures completely and always verify that the problem has been fixed by running the diagnostic test after the repairs have been made.